Yeah, it's my pleasure to have the opportunity to speak here. And I can absolutely agree with Raphael, it is an exciting time. Yeah? Normally, our profession, engineers, automation, is in the news only if something bad happens, plants blow up or stuff like that. But with Industry 4 in Germany, there's a lot of attention of politicians, the news, the press, and it's really in the evening television news that it is talked about how Industry 4 can, well, help Germany to, well, stay competitive. So this is really an exciting time, and there's a lot going on, not only on the technology side, but even on the, well, business and political side of it. So what I want to show you today a little bit is how we fit into that thing. And I'm not going to talk too much into the details of Industry 4. I will do that later on in the afternoon, explaining a little bit what it is, because that is a very far-looking concept. But what I want to do today is, or this morning, I want to give you an idea what we can do already today on that journey, on that road with Industry 4.0. Because there is a lot to do already now. There's no need to wait until everything is in place. Because, of course, the goals are reducing the time to market, being quicker, increasing the efficiency, and then there's all that concept how we can do that in a future system. But this is nothing that, well, we have to work and work and work, and one day we have the solution, and then we can do Industry 4 applications. We can start today already. And of course, communication is an essential part of it, what Raphael was already saying this morning. And I want to give you two examples what we do at PI already with our technology to do the combination of, well, IT technology, OT technology, what we can do if we mix information from different areas. And one is actually, well, let's say pretty old. That's something we started in 2009. And it was driven by an end user, by the automotive industry in Germany, because they came to us and said, okay, we have an issue with our plants. We're working normally on normal shifts, Monday to Friday. On the weekend, they're not used. That's how it is in Germany. Luckily, we have our weekends for leisure times. So do they. And they don't dare to shut them down. Because on Monday morning, at 6 o'clock in the morning or so, production has to start immediately, and they fear if they power down everything, startup will just take too long, there may be issues, so they let them run. And that's, of course, costing a lot of energy. And energy in Germany is pretty expensive, especially since we decided to opt out of all the atomic stuff and now go to renewables, so we have energy prices went up quite a bit. So for them, that was a real issue. And of course, we are engineers, there's always a solution to that. So they started to add additional hardware to it and just turn it off. Turn off the 24 volts, turn off the power of drives and all that kind of stuff. This, on the other hand, is a very unflexible solution, because then you have a normal program, PLC program in your controller, you have a program in the additional hardware to turn off the power. You need to synchronize all of that so that the power isn't turned off during your normal production. If you change something on one side, you have to change it the other side as well. So that doesn't really work very well. Unflexible system. So they came to us, we want to get rid of that. We don't want that. Can we get an integrated solution where all that stuff is working over the normal network? And this is where I think what is IoT, or what is Industry 4, doing the stuff over the network. And we came up with a technology we call ProFi Energy, which is basically a protocol extension to Profinet, which can turn on and turn off devices. So the controller knows, okay, I don't need that robot for the next 15 minutes. I don't need it for the weekend. And it just tells the robot, shut down. Like you would in your PC, hibernate or put it to standby or something, so to say, I don't need you now, and it comes back up when you need it. And the same thing here, the PLC can tell all the devices, don't need you for 15 minutes. And the rest, the robot does the rest by themselves. The robot knows how to save power. The manufacturer of the robot knows what to do if they receive the command to save power. So that's what we did with ProFi Energy, creating an integrated system with the network. And this is where really all the ideas of Industry 4 come into play. You say, okay, I have an information like a shift plan, and I combine that now with my automation world to save energy in the production. So you're mixing and combining different information, and with Ethernet, that's all very simple and easy to do. And this stuff is available now, and we've got great feedback on that technology. And even we can, again, like what was Matthew saying, prove the return of investment, because then we did measurements and say, okay, let's figure out what we really save with that stuff. It's nice technology, and as an engineer we love technology, but here's the proof of that it's really, that there's a big value, because we went in there, they installed the technology in one section, they measured the energy on that thing, and you see in the end, it was for them in a year 124 megawatt hours. And of course, with the price tag of the energy, you can easily find out how much money that is. And the technology basically comes for free. That's built into the product. It's part of the product. It's in there. No extra cost for that. Just need to use it. So one of the very simple ways to start with Industry 4 concepts right now, and just as one example. Then there is another example, and that's kind of the hype stuff. We love to talk about the cloud. The cloud is pretty cool right now, and cloud and big data is even more cool. So, but what does it mean for us? How can we use that stuff? And does it really change our business? Because everybody is now talking with, well, there's new business models coming down to us. And this is a great example. It's a company from the US. And what they did, or what they normally do, they built the automation equipment, everything for grain silos, to store grain in the silos. And they built the stuff, give it to the companies that operate them, and do the maintenance later on it. And in a grain silo, you usually have some elevators to put the grain into the silos, some to get it out again. You have temperature control, moisture control, so to keep it at a good level, so that nothing goes bad in there. And this is what they do, building the stuff all over the US on a big scale. What they figured out is there's often some problems. Well, if the grain, and especially in the elevator, things get stuffed, the elevator breaks down after a while of operations, they have to come in and fixing things, and then we come to the downtime issue Matthew was talking about. What can they do to change that? Well, first of all, they changed to an Ethernet-based system, PROFINET, so to have the information at hand. And then they added OPC to it to get that information to the cloud. And finally, they used data analytics to analyze that. And here comes the nice thing. Because they know their stuff very well, they developed the machinery for that. They went through the learning curve, how it should be, how it should behave, how it should work, what is a good operational state, what is bad. They know their stuff really deeply. And so they figured out, if we have the data from the machines and get real-time data, we can look at that constantly. And we can figure out, okay, there's something developing in the wrong direction. They know their stuff. And then they can call the plant operator and say, well, something doesn't look so good. We believe your elevator number 5 will break down tomorrow, the day after tomorrow, or something like that. We should fix it right now before it breaks down. And this is preventive maintenance then. And so that's exactly what they did. They implemented the system, ran the analytics, could call in the plant operator early, and then afterwards they could prove, well, here, look, your uptime in the past was, let's say, 75%, 80%. Now it's 99.9%. This is the value they can sell. And this is how they changed their business model. In the past, they were, well, building the facility, going back home, waiting for a call when something had to be fixed, and then coming in. Now they are part of the operation. They're basically part of running that thing, because they constantly look at the values, constantly monitor it, and, service and fix it before something breaks down. And of course, they can provide additional information, real-time reports, and all that kind of things, because they have the information they need with using an Ethernet-based system. And this is a reality today, something you can do today. And this is where I really believe in big data is working, especially for system integrators, machine builders, or people like that who build the stuff and know it exactly. For them, it's relatively easy to understand how to use data analytics to do preventive maintenance. It's much more difficult for the IT companies who just tell them, give me the data, I will find something. I don't believe in that easily, because you need to understand the system, then you can do all that kind of thing. So this is how one example how it will change our business models in the future. And the key really is that you have one homogeneous network. The key is really that you have the proper network for that, because if you have too many different networks, and well, here's field bus, and there's an Ethernet network, there's a separate closed motion control network, it's a hassle. It's not seamless communication. You have to have gateways moving data back and forth, and then it starts to get unflexible again. Like with the ProFi Energy thing, if its data is not flowing, if you have to constantly configure things, it's unflexible. But if you have one Ethernet system from top to bottom, then it's much more easy, and that's the usability part of it. That really enables solutions like that. Of course, there are different requirements on the enterprise level and on the field level. Field level is real-time deterministic, quick, small data packets. Enterprise level is usually big data. You need lots of bandwidth, but that doesn't matter too much if you have an Ethernet-based system. You can use gigabit on the enterprise level easily and things like that, and stay with PROFINET and IIoT stuff on the field bus level. That's Ethernet. That's the value of using a standard Ethernet network. And so this is what you should look for if you want to really use that technology. If you want to use Ethernet, use an open Ethernet system which doesn't change stuff and doesn't make it difficult. So with that, you can really use all that new requirements and to realize them. And PROFINET is not the only answer or the answer to every question. I believe, and that's the power of Ethernet, that you can mix and combine protocols. Like I said, PROFINET and OPC, for instance. It's like on your computer. For email, there's a certain protocol you use for emails, and then there's another protocol, HTTP, for websites, and then a million other protocols. But that's the beauty of Ethernet, that you can use all that different protocols. So use the right protocol for the right job. PROFINET is well suited for all the real-time automation, cyclic data transfers, small telegrams, because usually an I/O doesn't provide millions of bytes. It's small bytes. But OPC on this other side was made for structured, bigger chunks of data, moving data to a quality management system and things like that. And with Ethernet, it allows you to combine all that on the same network. It's one infrastructure. It's a PROFINET infrastructure throughout the plant, and you can move that data back and forth. You can have safety and all that kind of things on the same network. So that makes life easier, and that's what we call the PROFINET of things. We are doing that now since 25 years, basically. A lot of people say all that stuff is new. Of course it's new, but it's not really new to us. We started it 25 years ago, basically, with introducing PROFIBUS, and PROFIBUS idea was not to save on the cabling. Of course, you saved a lot of cabling in the past. You had all the sensors and actors directly wired to a big PLC cabinet, but the value of PROFIBUS really was the modularization, that you a machine all of a sudden only had one cable coming to it, a PROFIBUS cable, and then you could replace it more simple by another machine, or you could have multiple machine builders developing different parts of a production line and assemble that on your plant. The modularization was really the benefit PROFIBUS introduced 25 years ago. And then we started to use safety on the same network. So using the same network for multiple tasks, getting rid of specialized additional networks, so making it easy again. 2001, then we started with introducing PROFINET, and so that is not a young technology anymore. It's mature technology, and if you look at the numbers we have worldwide now, almost 15 million nodes already installed. So it's a mature technology that's proven in use, and that brought Ethernet to the field level. And then 2008, 2009, we started to look more to specialized profiles, what we call profiles, that sits on top of the standard protocol to introduce all that new fancy features like ProFi Energy. And this is what we are going to do in the future. So we have now our PROFINET protocol, that's stable. Now we add things on top of it to make it more easy for the user to use the technology for certain tasks in that Industry 4 environment. So I think we are very well suited for that. It's not all. What I showed you today was only 2 examples what we do. If you look at that slide, we're right now engaged in 1,000 activities around that, and Xaver Schmidt will later on tell you probably a little bit more about what we are doing. Just what I want to say to you, PI is a worldwide global association that develops the technology and markets the technology. And if you look at our members, who are the members? It's really the main automation companies, all of them sitting together, and that's, I think, what makes PI unique, that we have all of them in our working groups sitting together and work on all these different topics. There's a lot of stuff coming down in the years to come. How do we use gigabit? How do you use IPv version 6, for instance? How do we be more flexible with safety? That's a very interesting topic, because safety and flexibility is pretty much the opposite. You build a machine, you certify it for safety, and then you never touch it. But in Industry 4 environment, you need to touch it. You need to change it. How can you do that? Things like that, for instance. How do we use security? How do we make stuff secure? Thinking about security profiles and all that kind of stuff. So having a secure communication to devices. All this stuff is things we are working on right now. And ARC did a nice write-up on our technology and how do we fit into all that thing, and how, what we say, we are future-proofing for that for the next 25 years to come. So if you want to read that, there's for sure Raphael can get you a copy of that, or you can just simply download it from our website. Because the strength really is that we have a very stable basis. We have a long experience with PROFIBUS and PROFINET. We have millions of devices out there. We have a broad support of multiple vendors, and that's the beauty again. You're not tied to one single vendor. You have a broad variety of selection. You see some of them out there in the microfair. But on the other side, it's a future-proven technology. We use TCP/IP. We are open to all that IT stuff that's coming down, and I'm pretty sure you will hear more about that today during the day. So we believe that PROFINET is really the backbone for Industry 4 and can be used for that. And whether you call it Industry 4 or IIoT or Smart Manufacturing 2025 or something like that, there's all these activities throughout the world. In the end, it's about being more competitive in manufacturing. And manufacturing is a very important industry. In Germany alone, I think it's 17 million jobs depending on manufacturing, directly or indirectly. So for us, it's essential that we stay competitive in Germany. We're a high labor country. We have high energy prices and all that kind of things. But on the other side, if we lose that in Germany, we are really in big trouble. So that's why we put a lot of effort in there. The government is putting a lot of effort in there to keep Germany competitive, and you can participate on that because the technology is there for you to be used as well. Okay, thank you. That's what I wanted to share with you today. Thank you.